Hello my dear students. Hope you all are doing great. Today I have brought all the light practicals for you all. I know science is an interesting subject. So to create more interest in science, let us perform few activities which are related to our light chapter. Right? So let's begin. Our first experiment is related to reflection of light. So we should know what is exactly the reflection of light. Reflection of light means bouncing back of light when it strikes on a polished surface like mirror. Now let us understand the laws of reflection. Today I am going to show you the laws of reflection of light. So the first law states that angle of incidence is equal to the angle of reflection. And the second law states that the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. So let's start with the demonstration of the first law of reflection, that is incident ray, normal and the reflected ray. All three lie at the same plane. So let us understand what is exactly the plane. So you can see here, this is y-axis and this one is our x-axis. So the combination of two axes makes a plane. So here incident ray, normal and the reflected ray, all three lie at the same plane, and this is our smooth polished surface, that is mirror. Now let us perform this experiment with the plane mirror which is having a smooth polished surface and with a laser beam. Now here you can see the laser beam is incidenting on the point of incidence and it is reflected, right? So you can see this reflected ray, this point of incidence and the incident ray along with the normal all lie in the same plane, right? So here the first law of reflection, that is incident ray, reflected ray and the normal all lie in the same plane. So this law is proved here. Now let us understand the second law of reflection, which states that the angle of incidence means the angle between the incident ray and the normal is equal to the angle of reflection, that is the angle between the reflected ray and the normal. So let us understand how to measure the angle of incidence. So here I have kept the protector at 90. You can see this is a normal and I have marked angle of incidence as 60 degree. Similarly, I have marked angle of reflection. Yes. So you can see here this is also at 60 degree. This angle I is nothing but this is the incident angle and angle R is nothing but this is the angle of reflection. Now let us demonstrate with the help of laser beam. Now here I am just passing the laser beam from the incident ray, right? And it is getting reflected from the reflected ray. And you can see on passing it, the angle of incidence is equal to the angle of reflection, right? So here the second law is also proved. The angle of incidence is equal to the angle of reflection. Now we will learn about the refraction of light. Bending of light when it enters obliquely from one transparent medium to another, that is called refraction of light. Now how the bending of light takes place means what is the cause? The cause is the change in the speed of light as it moves from one transparent medium to another transparent medium. The speed of light gets changed and the speed of light is maximum in vacuum, that is 3 × 10⁸ meter per second. Now let us observe few examples of refraction, that is the bottom of swimming pool appears higher. A pencil partially immersed in water appears to be bent at the interface of water and air. Lemons placed in a glass tumbler appear bigger than their actual size. And the last but not the least, alphabets appears to be raised when seen through a glass slab. So let us observe all these activities with the help of the experiment. Here I have taken water in the glass, and now I am just going to show you that how the pencil, you will observe the path of the pencil will get changed. Can you see here? This is the original path of pencil, but it looks somewhat different from its original path. Why it is? Just because of the change in the speed of light, as it was passing from air to water. And air and water both are transparent medium. So the speed of light will get changed, due to which the bending of light will take place. That is called the refraction of light. Right? Now see, this is a lemon. This is the actual size of the lemon. Right? As I will place this lemon in the glass tumbler, you will find that this lemon will appear bigger in size than its actual size. Let us observe. So now you can see the size of the lemon looks bigger than its actual size. Yes, this is called refraction of light. Right? Here I want to explain you the refraction of light with one more example. As I hope you might have observed, the bottom of swimming pool appears higher than its actual depth. Why it is so? Just because of refraction of light. So here I am just trying to show you with the help of a coin. We will be able to see the coin is somewhat higher than its actual depth. Right? So let us observe. This is our coin. And now let's observe it. As you can see here, this is the actual depth. This is the actual depth, and we are observing somewhat here is our coin. Right? So this is also possible just because of refraction of light. We are able to get two positions. The below one is the actual position of the coin, and the upper one is the apparent position of the coin. So what we observe, the bottom of the swimming pool is somewhat higher than its actual depth. So this is the illusion. This is not an actual. It takes place just because of refraction of light. Now let us understand how the refraction of light take place through a rectangular glass slab. The extent of bending of ray of light at the opposite parallel faces of rectangular glass slab is equal and opposite. So the ray emerges parallel to incident ray. Here you will also observe one new term, that is lateral displacement, which depends on two factors. First one, the refractive index of glass slab, and the second one, the thickness of the glass slab. Now let us demonstrate refraction of light through a rectangular glass slab. For this we have to fix a sheet white paper on a drawing board by using the drawing pins at its four corners. Now we have to place this rectangular slab in the middle of the sheet, and we have to draw a boundary around the glass slab. After that, we have to draw a normal and we have to give a name to a normal N and dash. Now we have to place the protector at this point O. And now we have to mark 60 degree from the normal and then join this point with the point O, and this ray is our incident ray. This point O is nothing but this is the point of incidence. This is medium air, which is rarer. Rarer means which is having low refractive index, and this is our glass, which is denser, which is having more refractive index. Now we have to fix two all pins at this line incident ray. You have to just see the all pin must be erect. Then place the glass slab, and you can also give the name to this boundary as A, B, C and D. Now place the glass slab, and now we will observe these two pins at the opposite side of the glass slab, and we will also fix two more pins in the same straight line. Now we will observe the position of these two all pins in such a way that these two pins must appear in the same straight line. So let us observe. As you can see, this is the line, right? In which we can see both the all pins are looking in the same line. Now we will place two more all pins from the opposite edge of the glass slab in such a way that it will also appear in the same straight line. And here I will also apply one more all pin in the same straight line. Now here you can see all the four all pins are looking in the same straight line, right? Now we will remove the glass slab and all the four all pins. First we will mark the positions of all pins, and we will also name them as E, F, G and H. Now we will join these 2 points and extend this line till point OO dash. We will take this point as O dash. Now we will draw the normal and name it as M dash. We will also join these 2 points OO dash . Now this angle between the normal and incident ray is the angle of incidence. This is our refracted ray. So the angle between the normal and the refracted rays, angle of refraction. Again this ray is getting incident, so we will consider as I2, I1, R1 and this angle as R2. So here the ray of light is moving from denser to rarer medium again. So you can see it is when it is moving from rarer to denser medium, it was bending towards the normal. To find it, we will just extend this first ray of incidence in a dotted line okay. So you will extend this in the dotted line, and then you can see this incident ray and this emergent ray. This is called the emergent ray, parallel to the incident ray, and the displacement between these two, this displacement between these two, incident ray and emergent ray, is called lateral displacement or lateral shift. So in this way we have completed our activity of refraction of light through a rectangular glass slab. Now we will understand how the refraction of light take place through a glass prism. So first of all, we need to understand what is exactly a glass prism. A glass prism is a transparent object having 2 triangular ends and 3 rectangular sides. Now we will start with the activity refraction of light through a triangular glass prism. For this, we have to place the prism in the middle of the sheet and we have to draw its boundary as I have already done, and after that we have to name it as A, B and C. Then here we will draw the normal with the help of protractor, and then we will just meet the line and name it as N and dash, and this point as O. Now with the help of protractor you have to take the angle, mark the angle at 30 from the perpendicular and join this point with point O, and this point is O, and here this ray is incident ray, and the angle between the normal and incident ray is angle of incidence. Now we will place 2 all pins at random position and then we will place our prism at its position. Now we will observe the path of these 2 all pins from the opposite face of this prism. Now we have to adjust 2 more all pins from the opposite face in such a way that these all 4 pins appear in the same straight line. Yes, here I can see these 3 pins are in the same straight line. We have to take care while doing the activity that the position of the awl pin must be straight. Now one more awl pin, and now we can see the all 4 pins are appearing in the same straight line. Now we will remove all 4 pins as well as the glass slab. Carefully. First we will mark the position of all pins. This I am considering as position P. This one is as position Q, R, similarly S. Now we will draw a line so that both these points come in the same straight line, and that line we will extend till the, yes, it will cross our prism line also. So here I am just taking from here and extending at the back side also. Now at this point I will say this point is O dash, and now at this point we will draw a normal. With the help of ruler we will draw a line, and this line will draw in dotted. So this line I am taking as M dash, and now we will meet these 2 points O and O dash. Right? Now this angle is the angle of emergence, and this ray is our emergent ray. This line is the refracted ray, and now we will extend our incident ray furthermore. So we can see this point where our emergent ray and the incident ray are intersecting each other. This angle is known as angle of deviation. This angle is known as angle of deviation, and we can name it as point G, and this is our angle of prism. Angle A is angle of prism. So here we have written all the things: incident ray, refracted ray, and then emergent ray. The angle between the normal and the incident ray is angle of incidence. Angle between the refracted ray and normal is angle of refraction. Angle between the normal and the emergent ray is angle of emergence. This is your angle of prism, and the angle between the incident ray and the emergent ray is the angle of deviation. Now have a look on the characteristics of image formed by the plane mirror. The image is virtual and erect. Size of image is equal to the size of object. Image is formed as far behind the mirror as the object is in front of it, and it is also laterally inverted. Now, what is lateral inversion? The right side of the object appears left side of the image, and it's vice versa. Let us observe the characteristics of the image formed by the plane mirror. Let's start. Yes, you can see the first characteristic is the image formed by the plane mirror is virtual and erect. So you can see the erect position of the image which is forming inside the mirror. So we can say it is virtual in nature because this type of image cannot be formed on the screen. Right? So this is our virtual as well as erect image. Now the shape and size of the image formed by the plane mirror is the same as the size of the object. Now let's talk about its position. In position you can see the distance between the mirror and the object is 4 cm, and the image formed inside the mirror is also 4 cm. So it means the image formed by the plane mirror will be at the same distance as much the object is placed in front of the plane mirror. Right? Now let us observe one more characteristic, that is lateral inversion. As you can see, I have written few letters here on this white sheet. AMBULANCE. Yes, that is ambulance. Let us observe how it will look in the plane mirror. So, I am just going to show you this in the plane mirror, and you will see this. This is ambulance, right? I hope you all might have observed that it is written in laterally inverted. Means the left of the object appears to be the right and the right of the object appears to be the left. This is called the lateral inversion. Now we will learn about the dispersion of white light by a glass prism. So first of all, we should know what is exactly the dispersion. When white light is passed through a glass prism, it splits into its 7 constituent colors to form a band of 7 colors. This phenomenon is called the dispersion, right? First, we will observe the rainbow formation by using a glass prism. Okay dear students, today I'll perform an activity to show the dispersion through a glass prism. So first of all, you can see this is our glass prism, which is having 2 triangular surfaces and 3 rectangular surfaces, as you can see. Now I'm going to show you the dispersion of white light through a glass prism. White light is nothing but this is our sunlight, right? So here I have taken a white sheet as a paper as a screen. As you can see, this is the rainbow formation, dispersion of light. You can see the tinge of red, orange, yellow, green, blue, right? So this is our dispersion of white light. Dispersion means splitting of white light into its 7 component colors, right? I hope now it is clear to you how it observes as a rainbow. Now we will observe the rainbow formation by using glass of water. Okay children, so you can see we have taken water in the glass, and now the white light is passing through this glass and we are able to get this rainbow on our screen. You can see the tinge of red, orange, yellow, green, blue. Our rainbow is shaking just because of the water is shaking in the glass. So here it is the rainbow formation. Now we will look at the rainbow formation by using water spray. Okay children, so now we'll observe how we can form a rainbow with the help of water, as water droplet act as a prism, right? So I have taken water in this bottle and I have taken a spray. Okay, now I'll do the spray and you will be able to observe the rainbow. Now see. In this manner you can form the rainbow in your home also. Hope you all have enjoyed all the experiments based on light and understood the concept well. For any doubt, you can ask in the comment section. Don't forget to like, subscribe and press the bell icon for more upcoming informative videos. Thank you.